everybody, welcome to your first video. We're going to jump right into 1.1 Introduction to Graphing. So on your papers you're going to see that you have an XY axis for graphing. So this guy right here is your x-axis, and then we have our y-axis. The origin is that spot where those two axes meet, and that point is known as 0, 0. In the Cartesian coordinate system, your first number is the x value, your second number is the y value. When you plot those points, so if we're going to graph and label these 2 points, I'm going to call this one A and this one B. You're going to first plot the x value, or go to the x value and then go to the y value, and where those two meet is where you're going to put your point. So we're going to -3, 5. So left 3 units, up 5 units, and right there we're going to put a dot and label that A. Then if we're going to +4, +3, again where those two meet, putting that and labeling it with a capital B. So just a reminder on how to plot points. So whenever we have solutions to equations are going to look like an ordered pair x, y, if the equation has an x and a y in it. So really what we're checking to see is when we plug in that ordered pair, does the equation work, or is the equation true? So we just want to be able to substitute in this value and check to see if it makes a true statement. So looking at example number 2, we're going to go ahead and plug in -5, 7 into the equation. 2x + 3y = 18. Remember, first number is x, second number is y. So when we substitute these in, I'm looking at 2 times -5 plus 3 times 7. And we want to know, does that equal 18? I'm not sure, because I want to know if it is or is not a solution. Simplifying this further, I get -10 plus 21. Is that 18? Well, no, 11 does not equal 18. So this is not a solution. Testing the second ordered pair, 2 times 3 plus 3 times 4, we want to know if that equals 18. 6 plus 12 when we multiply those, and yes, 18 equals 18, so yes, this is a solution to that equation. We have 3 different forms of linear equations that we're going to work with. First one is slope-intercept form. Y equals mx plus b, where m is your slope and b is your y-intercept. Point slope form, y minus y sub 1 equals m times x minus x sub 1. M is still your slope, but now we have a point, and that point is x sub 1, y sub 1. Lastly, we have standard form, ax plus by equals c. And the key characteristics about standard form is that your that number in the front, that number touching x, must be a positive whole number. The right side of my board gets a little crazy. Must be a positive whole number. All right, your slope formula, you'll notice that both slope, intercept, and point slope, you need to know a slope. So that slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. All right, we're going to talk about ways of graphing when we come to class together. And then I'm also going to go ahead and graph these 2 with you. So we're going to jump down to example number 5. For this example, we want to write the equation of a line containing these 2 points, and we want to write it in point-slope form. Point-slope form, just to remind you, y minus, it's getting a little crazy over there. Let me try again. Y minus y sub 1 equals m, x minus x sub 1. So first thing we have to find is that slope. I'm going to go ahead and label these x sub 1, y sub 1, x sub sub 2, y sub 2. Your slope formula, if you flip back to the other page if you need it, we're going to take y2, so 0 minus y1, 3, and 4 minus negative 1. Simplifying this to negative 3 divided by 4 plus 1 minus the negative changes there, which would give me negative 3/5. Now when we're doing point slope, you can pick either point that's given to you. So if we want to use the point negative 1, 3, then our point slope equation is going to look like y minus the y value equals my slope times x minus the x value. So x minus the negative 1 would change that to a positive. Then if I'm going to go ahead and do this other point, which is not necessary, you only have to do one of the points, so you'd be done with the answer in green. But if you chose to use the other one, then you're looking at y minus 0 equals your slope, x minus 4, and then you would simplify this one step further to y equals negative 3/5 x minus, this right side, 4. Okay, that got a little crazy. That's a minus 4. The only thing to think about in this one, this is not slope-intercept form because you would need to distribute that negative 3/5 to get it into into slope-intercept. So this is still an acceptable point slope form solution, even though it looks a little bit different. That y value was 0. All right, example B here. We want to write this equation of this line, but now in slope-intercept form. So slope-intercept form is y equals mx plus b. Again, we need to know a slope. So let's go ahead and find that slope to start. We'll take our y2 minus our y1, changing that to a plus, x2 minus x1. So this would simplify to negative 2 divided by negative 3, which would give me a positive 2/3 slope. Now, if you look at these two ordered pairs, because this guy has an x value of 0, I know that this is my y-intercept. That is where my graph's going to cross the y-axis. So I don't need to go ahead and plug in a point to find my b value. I already know that that's b. So I can go ahead and write my equation right now, y equals 2/3 x minus 2, and that is slope-intercept form. All right, we're going to save example number 6 to do together. So going ahead and jumping down to the distance formula. Distance between any 2 points is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. This is also known as the Pythagorean theorem. All right, so we're going to find the distance between each of these points. I'm going to go ahead and do B with you, and I'll save A to do in class. So let me just get a little bit more room down here. I've got x sub 1, y sub 1, x sub 2, y sub 2. Using that formula that we just wrote down above, this is going to look like the distance is equal to a big square root. Let's go ahead and take x sub 2, negative 1, minus negative 1, quantity squared, plus y sub 2 of 2, minus y sub 1, quantity squared. Simplifying this, this is going to give me negative 1 plus 1, 2 plus 5, negative 1 plus 1 is just 0, 7, 0 squared is 0, so I just get 7 squared, which is 49. Square root of 49 is 7. So I know the distance between those 2 points is 7. And again, we'll come back and do that first example together. All right. Going to this next page, example number 8, we have the point negative 2, 5 is on the circle that has 3, negative 1 as its center. So I know this is a center, and this is just a point. We want to find the length of a radius of the circle. Length is also known as distance. So I know that I have a center point at 3, -1, and then I have a point anywhere on the circle at -2, 5. I want to know the radius. Well, that's just the distance between those 2 points. So we're just going to go ahead and use the distance formula with these two. So our distance is going to equal a big square root. We'll go ahead and take that x2. So we'll take 3 minus a -2. I'm going to change that to a plus right away. And then -1 minus 5. Simplifying this, 3 plus 2 is going to give me a 5 squared. -1 minus 5 is a -6. When you square a negative, that is going to give us a positive value back. So this is going to give me the square root of 25 plus 36, or the square root of 61, and that does not simplify, so that would be the distance or the length of the radius. All right, our midpoint formula. If I want to know the middle between two ordered pairs, that midpoint formula is going to equal the 2x values added together and divided by 2. The 2y values added together divided by 2. And again, it gives you back an ordered pair, so just make sure you do the x's first and the y's second. All right, example number 9. We want to find the midpoint of the segment whose endpoints are -4, -2, and 2, 5. So pretty straightforward. In example number 10, we want to write the equation of a circle having a radius of 5. So I know this is my r value. And center is 3, -7. So this is an h and this is a k because that's the center of the circle. So using that formula that's written above, this equation is going to look like x minus 3 squared, y minus the -7, so that would change to a plus, and that equals 5 squared, which will give me 25, and that's the equation of that circle. Working in reverse here, we want to know the center, and we want to know the radius. We have the equation. So the center point of the circle, we're just looking at that ordered pair, h, k. So this is going to be our h value, this is going to be our k value that we plugged in. But just remember it's x minus h, y minus k. So it's going to be the opposite of what's in there. So this center point is going to be a -5 and a +2 for the center point. The radius gets squared in the equation. So this becomes 4 for the radius when we take the square root of 16. Alrighty, that is your video lesson for 1.1. And when I see you guys in class, we'll go over the rest. Thanks for tuning in.